Hey everybody, welcome to episode 5 of the Blueprints to C++ programming series. Today we are covering the basics of the TArray. So let's have a look at the outline. So this will be a real short video, just covering the basics of function calls with TArray, of the iteration types, and the comparison between blueprints and C++. These slides, as now always, will be found on my GitHub account, which I will link down in the description. So let's have a look at code first. Here I have a small simple graph just to highlight all the important array functions. And I guess we start from the top. So what we have is add, insert at a specific index, have append to append another array, call the length or the last index function, getting an element, check if this array contains an element, or find the specific index of that element, remove an element, or remove an element at a certain index and clear the array. So if you're used to blueprints, you probably have used these a lot. And let's have a look at code, how it's done in C++. So let's have a look at adding elements and arrays. So we define an array. We have our other array, the vec array, just a simple U property in the header file. So we are adding a local array, adding a vector to it. So you call add, and the vector, let's have a look first. What you sometimes see here, where you have 0, 0, 0, just as a hint for vectors, if you're typing f vector colon colon, you have the 0 vector, and you have, I think, a 1 vector as well with all elements ones. So this is what I use most of the time when I want to initialize something, or when it has to be 0 or a scale vector of all ones. It's better to use these than to create a new vector with these elements. So here we adding a new vector to it, the array, then the insert function, adding the element at the specific index, or now when we have the array filled up, we can append it, for example, to the vec array. Then these were these three functions. Let's have a look at length, last index, and get. So in C++, what is called the length in blueprints is called num here. And this is how you get the number of elements. That's the difference that you have to figure out in looking for length, but there is no length in the vector, so it's called num. And there is also no last index function in the array, but you just have to call num minus 1. And then you get the last index that you're used to in blueprints. And the get node that you see is nothing else but using the standard access operator with the brackets on the array. One thing I want to stress again, if you're seeing this, is especially if you have structs, really try to make sure or look at things where you either getting structs out of an array, a set, or a map, or you are passing structs on function calls and so on. Make sure or have a look where it's really needed to make a copy, or where a reference really can be passed or got from the array. So here we are having a reference, because it doesn't make sense to make a copy if we are reading values. We can even make a const out of it to make sure we are not changing the element, but there's no reason to make a copy unless our function returns. If we have this in a function and our function returns a new vector, then you can create a new vector like this without the reference. But if you're reading most of the time and so on, make sure to always get the reference. This as a side note. So these were these nodes. Let's have a look at find and contains, like these ones here. In C++, there are three different ways. Okay, we have the contains, that's the same one, where you check to see, does the array contain this 0 vector? And if it does, it returns true. Then you have the find method, which in its first variant has only the element and returns an index. And then you would check to see, okay, is the index not equals the index none? That means it's found. And if it returns the index none, then then you know it's not found. So it's like a contains, which gives you back the index as well, and you use the index as before the if statement. And the variant 2 is you define a out parameter index, you call find, this find returns bool and returns the found index if it's found something in here. If not, then it's again index none. So these are the two different variants of finding, and then you have contains. And then lastly, we have, before we go into iteration types, we have remove index, and clear. So again, different naming conventions. Remove is the same. Remove add is the remove index, where we move the element at that index that we specify. And clear is called empty in C++. In the slides, you can find a recap of this, of all the what's called in blueprints and what the specific function call is. You can see it here again for all these functions. Let's go to iterations. In blueprints, you have several possibilities of iterating over arrays. Here, for example, we're looking at the for loop and the for each loop. The for loop returns just the index, and you need to get the index with the get node. And in here, you return the array and the index and the element. In C++, there are 3 different variants of how to iterate, so let's have a look at them. The standard for loop, like you've seen in blueprints, you just have your standard for loop with getting the number of elements and either going like I less than num, or you get the last index, like if you're used to what blueprints does, and go like less than equals the last index, but it's the same. And then you access it with the index. Then we have ranged based for each loops, which I use most of the time if I don't need the index itself. So here you declare your variable, which is also a reference in here, like I mentioned before, which is really important, and have a colon and the array itself. And then you have your variable already in the for loop that you can access. The same range-based version you can do with auto, which is like a new C++, I think 11 keyword, which is similar to the var keyword in C#, which automatically specifies or finds the actual type, and you don't have to specify it. Like if you see down here, we're using for the iterator, where it's basically a t-index container iterator. If you can't remember those specific structs and classes or whatever that are in an array, then you can use auto. But for simple stuff like vector or int, I just declare this, like the real type. And then the third option is using iterators. So there are 2 types. You create a standard iterator where you can change the value, and then you can create a const iterator where you need to define the variable as const and can just read it. And you assign the vector or the element with the star and the pointer to the iterator. And these are the iteration types. So as a recap, again in the slides you can find all these types again: the standard for loop, the range-based for loop, and the iterators. And at the end, again, some important functions again: add, insert, contains, find, num, and so on, what they do. But you've seen all that. So like I mentioned, this was a real short video. The next one will be about tset. After tset will be tmap. So these will be short videos like this one that just explain how to use these collection classes in C++ and how they differ to using in blueprints. Then thank you for watching, and if you found this video really helpful and want to be notified when new ones are coming out, then please subscribe to the channel. That would really help me a lot, and like the videos. And then I guess I see you in the next one. Take care. Bye bye.